Okay, so today we're going to look at set notation and Venn diagrams. So our learning intention is to gain the knowledge of the language of probability and the skill in writing set notation and reading Venn diagrams. So we'll be successful if students can correctly define the terms outcome, sample space, event, and set, define the terms union and intersection, and calculate simple probability. Okay. So, an outcome is all possible results of a random experiment. The sample space is the list of or the set of all possible outcomes, and the event is a set of one or more outcomes. So, for example, the event is rolling a die. Yeah? And so the sample space or the outcomes will be the sample space at this point would be the numbers 1, 2, 3, 4, 5, and 6. And if I rolled a 4, that will be one outcome. Or if I rolled a 2, that would be an outcome. But the sample space is 1, 2, 3, 4, 5, 6. So the event of flipping a coin will be heads or tails. And the outcome would be one of those. So the letters of the alphabet would be the event. The sample space is all the letters in the alphabet, and one of the letters will be an outcome. Okay. So the probability formula is the P of E equals N of E over N of S. So it's read as the probability of event E occurring is equal to the number of the events that we like over the total number in our sample space. Okay. So for example, picking a picture card from a deck of cards, so the probability of a picture card So there will be there's 3 cards to a suit. So the probability will be 3 over 13. Okay. The probability of a vowel picking a vowel from the alphabet. Well, there's 5 of those over 26. Yeah. And then picking a prime number between numbers of 1 to 10. So prime number so the sample space in this case would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the primes will be 2, 3, 5, 7. So we've got 4 over 10. Okay. Alright. So set notation. Notice that when I was writing my sample space, I divided my set or my sample space. Another word for sample space is the set in curly brackets. Okay. Okay, so we can also have these symbols here. So we've got A, this kind of U shape, so it's A union B, and that means we want everything in set A or in set B. So everything in set A or in set B. Okay. And when we have A and it's like an N shape, B, so that's A intersection B. So that means we want just the stuff that's in A and B, the things that overlap. So anything that is in set A and B at the same time. Okay. And A with this C, B, so this is A is a subset of B. So we can have another set within a set. Okay. And when we have a line above it, means the complement of A, or not in A. Okay. So we can construct or display our sets in Venn diagrams. And here's some examples. So here I have two sets, A and B. Obviously, note that if I just want set A, I'd say that I'll just put A. Obviously, if it's just set B, it's over here in B. If I wanted everything in everything apart from whatever's in A, I'd write it as A dash, or I could write it as A not in A. Yep. Notice that if I wanted everything apart from what is in B, I could write it as B dash or not in B. Okay, so here is the union that we were talking about, A union B. So this is everything in A and in B at the same time. Okay, so that's the union. If I wanted A and B, or sorry, A intersection B, yeah, it's just that little bit in between that happens in A, but it also happens in B. So there's some visuals. So that's A union B, so union, and A intersect B. Okay. So obviously, if I wanted everything else apart from that, well, I can write it as the A intersect B dash, or not in A, or the union of not in A and not in B. Yeah. So the union of not in A and not in B. Here I have the intersection of not in A, but has to happen in B. And here we have the union of happening in A, but not in B. Okay. If we want everything else that doesn't happen in either sets, we have not in A intersected with not in B, or the union of A and B, the complement of the union of A and B. Yep. Not in A union B. Here we have A union not in B. Not in A intersected with not in B, and A intersected with not in B, union of not in A intersected with B. Okay, and there are some possible options when using two Venn diagrams and using the set notation. Okay, so let's do an example. So if we have A and B, and the universal set is this, we want to construct a Venn diagram to represent the above. All right, so all we do is we create a large box, and this box represents the event. Yeah, so this box is E. Okay, we construct two circles with some parts that overlap. Let's call this A, we'll call this B. Okay. We look at the set of A. So there's 1 here. There is 3. There is the number 7, but 7 also happens in B, so we write that in the middle. And then we have 10. Yep. And so everything else should fall into B. So we got 4, 6, 7 we've already written, 8, 9, 2, and 5. And all these numbers should be here. So we've got 1, we've got 2, 3, we've got 4, we've got 5, 6, 7, 8, 9, and 10. Beautiful. Okay. So if we want to show that A union B is the same as adding all of A, all of B, minus the intersection. Yeah. So so we want to figure out everything, all the numbers that are in here, and we kind of know that it's going to equal to 10. But let's figure it out. So we've got everything in A, so there's 4 numbers here. So we've got, and notice that we write the count of a set in those straight lines. So the number of events that happen in A is 4. The number of events that happen in B was 2, 4, 6, 7. And the part that happens, the intersection of them, is just 1. Yeah. So the union, all the numbers in there, must be 4 plus 7 minus 1, which is 11 minus 1 is 10, which is the union, which is the whole event, okay? All right, so let's calculate the probability of A occurring. So the probability of A occurring, so it happens, there's 4 numbers in A, so 1, 2, 3, 4, and that's over 10, because it's 10 numbers in total. The probability of B occurring, we notice there was 7, that's 7 over 10. So the probability of A union B, so all numbers, right? So it wouldn't be 11, it would be 10. And in this case, that would equal 1, which makes sense. And the intersection is that middle part here, and well, that's 1 over 10. All right. Let's construct it. Let's have a different set. So we're still using, we're going to now use the numbers from 0 to 10. Okay. So we're going to have, this is A, B, okay. So there's no 0 in any of them, so I'm going to write that on the outside. Okay. 1 happens in A, 2 does not occur, so we put it on the outside. 3 happens, but it happens in both sets. Put it inside. 4 happens in B. 5 does not occur, so we put it on the outside. 6 occurs in B. 7 occurs in both. 8 occurs in B. 9 does not occur. And 10 occurs in A. Okay, so now we have the total number in the experiment is 0 to 10, so there'll be 11 numbers. Okay, if we want to figure out the probability of A, so that's these 4 numbers, that's going to be 4 over 11. The probability of B is these 2 plus these 3, so that's 5 over 11. The probability of the union of A and B. Okay, so that's obviously all of A plus all of B minus the intersection. So, or we can just add each number that we see. So we've got 1, 2, 3, 4, 5, 6, 7. And it's a total of 11 because there's 11 events. And the probability of A intersection with B is 2 over 11. Okay, and that's it. Thank you very much.